I think we're going to get started here. Thank you very much for joining us today. I am Tricia Davis-Muffett from the public sector team, and this is Leo. You want to introduce yourself?
Can everyone hear me?
Yeah.
I'm Leo. I'm a solutions architect here at Amazon Web Services, and I work with public sector customers on making sure that they architect their solutions to best practices on AWS.
So what we're going to talk to you about today is a little bit about what it takes for governments to adopt cloud computing, what we've seen here, what we're seeing in other parts of the world, the steps that they have to take, as well as focusing on telling you some stories about customers who have had real benefits in time and money, what they're doing with our technology, and then Leo's going to give you a deep dive on one of the case studies. So just in terms of where are we in adoption of AWS across the public sector, it's been pretty phenomenal in the past few years. We really only set up a dedicated public sector team about 4 years ago, and we are now at 900 plus government agencies. And we're finding adoption across all kinds of government agencies, cities, counties, local and regional governments internationally, as well as on the national scale, civilian agencies of all kinds doing all different kinds of use cases, as well as defense and intelligence agencies.
So we've got 11 regions around the world. We just added our latest region in Frankfurt a few weeks ago. And each region is basically a separate cloud, right? So they're all in different geographic areas. They have copies of the various AWS services in them. And then each region is broken down into availability zones. There's 28 availability zones. Each region has at least 2 of them. Each availability zone is designed to have distinct tier 1 internet service providers, distinct power. They're designed to be built on different floodplains and fault plains. And then there's edge locations where our CloudFront, which is our content delivery network, and our AWS Route 53 service live. So there's a special region in the US. So in the US we have 3 regions that are for all customers, and those are our East Coast region in North Virginia, our West Coast 1 region, which is in North California, and our other West Coast region, which is Oregon. We also have another region called GovCloud. So GovCloud is an isolated AWS region. It is designed for government agencies and customers that work with government agencies, and is designed for ITAR compliant workloads. So if you have a workload that needs ITAR compliance, you can go through an onboarding process and you can get onboarded into the GovCloud region, and you can start launching your workloads in there. The other thing that's unique about the GovCloud region is it also has FIPS compliant endpoints for all of its API endpoints. So just to talk about this really quickly, this is a Gartner Magic Quadrant for infrastructure as a service. And the thing that's really important here is just to show kind of our position in the market. So the same Gartner report estimates that we have 5 times as much compute capacity as the other 14 cloud providers on this chart combined.
And this really matters, especially in the government agencies that we're working with. Many of them really rely heavily on Gartner to advise them on what is the best way to go. So this has been pretty compelling for those, especially US federal agencies, but many national governments who really rely on their expertise.
So we're used by government agencies and educational institutions all around the world. I specifically specialize in educational institutions, so those are most of my customers. So we've got universities such as Notre Dame, we've got nonprofit institutions such as PBS, we've got federal agencies, the USDA, National Institute of Health, and they're all running workloads on AWS. And we also have a really big partner network. So we have different kinds of partners. We have software partners, such as Adobe and Oracle and Microsoft, and so they write or release software that you can use on AWS. So some of that software is also available in our marketplace. So you can go to our marketplace, you can pick the solution that you're looking for, and you can just one-click launch it and the billing is integrated into it as well. And we also have ISV partners that will help you migrate your workloads or write your applications into the cloud. And these range from your DLT Solutions, Deloitte, all kinds of different companies out there too.
And in terms of the use of these solutions that are available in the marketplace for education and government, we actually have just in the last year created a category within the marketplace for educational institutions, and we also are creating a unique experience for those who are looking for government applications, which that's in process now. So in terms of, what is it that, that the government is doing and why are they doing it? Everybody has heard a lot about how much less expensive it is to work with Amazon Web Services, and I do think that's certainly compelling. This quote here was from Terry Halverson, who is, at the time, he was the CIO of the Department of the Navy. Now he's actually the acting CIO of the Department of Defense overall. And he actually was really kind of breaking the mold when he moved his applications and websites to Amazon Web Services, because he was really working through a third party within the government, SPA-WAR, in order to move things to us, because it was not really within department policy for him to move his workloads to AWS, but the savings were so compelling that he did so. And now he's been really championing that for across the Department of Defense, and it's been very compelling for them as well, because just recently, in the last couple of months, we've gotten approval through the DISA cloud security model, commercial cloud security model, to really do any unclassified workload. So they classify workloads in levels 1 through 5 in the unclassified space. We are now approved to take on any of those workloads. So in fact, just last week, he was speaking at an event called Fed Talks, and he said that he was going to launch a 12-step program for government officials to release their data. So he definitely sees the cultural aspect there, but the benefits are so significant, especially in times when the defense budget for IT is not growing. So the way that we think about the public sector, and especially government, why we're doing what we're doing, and the main missions of this team within Amazon Web Services is twofold. One is in paving the way for disruptive innovation, so making it easier for governments to adopt cloud computing. So I'm going to talk to you a little bit about that and what those steps are and what we've been working on with the government. And then really doing workloads that make the world a better place. So most of us who are in the public sector are doing that because we are mission driven, and so that's sort of what drives us. So I want to talk to you about how those things are connected. In terms of paving the way, we've got what do the customers look for, and these are the things that we're going to talk about. They need the kind of innovation that disrupts the status quo. They need agility, and that time savings we are finding actually is more compelling sometimes than the cost savings. So I talked to you a little bit about the cost, but what we hear from many of the government officials is they just can't wait to get things done that have to be done, especially when they're in the face of mandates or major social problems or deadlines that can't move, which you're going to hear about some of those today. And then they need capabilities. They need things that they maybe can't get access to in another way. And then, of course, the cost savings, because they're not in times of expanding budgets. Now, when we look at what's required, and we see this as we look across the world at what different governments are adopting, you can't just jump right into broad adoption of cloud computing. You can't just say, hey, you guys should all do this, and then just go ahead and do it. There are a lot of steps that have to happen first. So really what we've been seeing is there are those two foundational pieces at the bottom that are the first steps that a government has to take. In the US government, they did that quite some time ago. We had a cloud-first policy that was issued by the Office of Management and Budget. We've now seen that issued also in the UK. We've seen it issued in parts of Canada, in parts of Australia. We've got people sort of thinking about it in other parts of the world. Singapore, Japan is thinking about it as well. So there's a policy directive. But then there's also a definition. And I take a little responsibility for the struggles here. I worked for a few other IT companies before I came here. there's a lot of muddied waters about what it is that's a cloud. So really laying out what is cloud so that you know what it is that you're mandating when you say cloud first. So those two pieces go hand in hand because the policy doesn't really have any teeth until you've got a government definition of what is cloud. So in the US, we've seen NIST really take the lead on this, and other, in other countries or other organizations doing that. Then once you do that, you've got to figure out what are the security and compliance requirements. Do you have data sovereignty laws? Do you have what kinds of data needs to be in different categories? Just like I was talking about with the DoD model, you have to have that definition and figure out what is required and what are you going to ask your cloud computing providers to do. And then you put a standard in place and you ask people to meet it. So that's what we've done in places around the world. And we've got assurance from our Vice President, Teresa Carlson, there is no bar that we are unwilling to meet. So every time that somebody comes out with a new standard, we work to meet that standard. So far we've met standards. We've been among the first to meet standards, the FedRAMP standard in the United States, these DoD models. Also, we just met a standard in Singapore. We also met another standard in Australia. So anytime that one of those security regimes comes out, we meet it. But that's really required because if you don't have it laid out, you can't get there. The next step, really a challenge, is procurement. So we definitely have seen this in the United States, where I'd say this is about where we are or where we have been in the last 6 months or so in the United States, is starting to see acquisition officers really start to understand how to acquire cloud. The forward-thinking acquisition officers. And it's in other places too, where they have to get used to not specifying, I need this amount of storage available to me at this time, or I need this specific box, or I need, they're used to doing that, where they're sort of laying out, here's my order, what will it cost? And instead, really getting to something that we've been talking about in the US government for more than 10 years, which is thinking about the performance and what it is that you're trying to acquire, what's the capability you're trying to acquire, and then letting the commercial company come to you with what that will take. There are a lot of different pieces to that, and we're doing a lot of education in the market to help people understand how can you access cloud computing, how do you build a procurement that will actually allow commercial cloud providers, not just Amazon, but other cloud providers as well, to bid on that. And it's, sometimes they don't even mean to be excluding commercial cloud providers, but just by the language included in the procurement, it does. So there's a lot of education in the market, but that really takes both the government and the commercial side educating the marketplace. Then we get to the point that I mentioned earlier about culture, and we have another story in here about culture as well, but really trying to change that culture so that people don't feel threatened by the fact that they won't be, doing the care and feeding of their data center with all of their employees, and that there really are other things that they could be doing that would add value, and trying to help get people to a point where the culture can adopt cloud computing. And then once you've got those things, that's when you can finally get to the point of broad adoption. So as I mentioned, the security requirements, this is just a list of the number of security requirements that we have. You can see those new ones down at the bottom. So that's the DISA standard that I talked about in the commercial security model. IRAP, that's the Australia one. And then the IDA, which is Singapore's model, that's MTCS level 3 that we have met. So why would we pave the way for this? What does this all end up doing? It really ends up in real change and disruptive innovation. So, I laid out those things, those reasons that we are, how we're making the world a better place. The two that we talk about in government are primarily enabling economic development and improving citizen services and engagement. So, a great story about the Singapore Land Authority this is the One Map, which is the GIS program that they built. And it's really been a national portal that makes open the GIS data that they have and then really partners with the commercial sector in order to help build economic activity around that data. So we're seeing, especially in many areas, these kind of open data projects that are driven by the government that end up driving some significant commercial activity. So that can really be an economic development driver. And it really makes sense for those things to be done through cloud computing, because if that's really your end goal, is to make it open to anyone who might make use of the data, then the best model is to go with commercial cloud. This is an interesting one. So the Department of Homeland Security, U.S. Citizenship and Immigration Services, they're the folks who do lawful immigration to the United States. Their CIO, they had a new CIO who came in from Silicon Valley, and he sort of came in and said, okay, we've got some new requirements that we're hearing. Let's take care of this. Let's add some capabilities to our application process and the workflow that we're doing. And he sort of got a lot of blank stares and said, well, okay, well, we could probably do that within the next year. And he was baffled by this and said, if you just sit me down in front of the system, I can take care of this in a couple hours. And they said, yeah, we could do it in a couple hours too, but maybe we could do it in 8 months. So finally, he got to the bottom of it, that really they were following a waterfall methodology that had been laid out in their software development lifecycle that actually was mandated from a management mandate that came from the creation of the Department of Homeland Security in 2002. And this was this year. So, he had to really go back and, in order to take advantage of current technologies, go and change policies. He actually got himself on a committee to rewrite the management mandate. He changed them from a waterfall methodology to agile development. And now, they're using Chaos Monkey and they're using DevOps, and they can actually make changes. But really interesting that the blocker there, although the ultimate result was that they switched over to our technology, the major blocker was not even how easy it was to procure or the decision to move the technology, it was the policy. And I encourage you to watch the video. He's actually an excellent speaker, and he gives a 30-minute talk on how he did this, and we've provided it here, so when you grab the slides, you can see that. Another interesting story, Transport for London, and we've had actually a number of use cases for transportation systems, both in the US and internationally. You think about people who interact with a transport system, there's a lot of information they need. It changes all the time. It really needs to expand because you've got visitors coming in, you've got a growing population, a more demanding population. So they're trying to be flexible, build new applications for their riders of their transport system, the people who are using the roads. And so they really have to be able to expand and not add budget in order to do that. So Transport for London has been a fantastic customer of ours, and they're really having significant savings on the operational cost while they're adding capabilities that help riders to make use of the system. And this was particularly important when they were having tube strikes, and they had people all over the website and trying to figure out different ways that they could get to work and get around the city. And so they had to expand, and they could never have known that they were going to have to do that because it was an unexpected challenge, but everything worked. So that was critical for them. The CDC, again, this is really helping to improve the lives of citizens. Of course, the CDC is provided, they're trying to deal with all kinds of health crises and trying to pull together data. This has been a big data application for them to put together all of the information coming in and try to figure out where are outbreaks, how can we cope with them. They did this with the BioSense application and moved to the AWS cloud, and it allowed them to help create jobs and to expand their capabilities and to have better situational awareness as outbreaks occurred. The US Department of Agriculture, again, this is one where they were it's a sad story in that the state of the economy was driving a lot more people to use food stamps who had never used it before, the SNAP program. And those people didn't really know, where can I use the food stamps? How can I find out, how can I get access to my benefits? And so they really were struggling. And so this was becoming a crisis point. And they were given 3 weeks to solve it and to be able to cope with this challenge and get something up. So they moved on to us. They really weren't sure it was going to work, but they moved on to us, and now they're making use of GIS data to help people identify where can they take this. And they've actually, that was the crisis point that caused them to move, and it really was a time issue rather than a money issue. But now they've actually rolled it out into additional services that they're offering, and they estimate that it has cost them only 10% of what they had budgeted. So that's money that can go back into providing their essential mission, which is to give benefits to people who are hungry. Another GIS story, we've had a lot of great GIS stories, is Douglas County, Nebraska. They're actually the biggest, most populous county in Nebraska. And they're doing all of the different activities that rely on GIS, so property information. And we're actually seeing this is the Douglas County story, but we actually had one of the winners of our City on a Cloud competition that we had in the summer was another one that was doing this kind of city planning and making use of GIS data. That was for the city of San Francisco. So they were really, this was a unique one because these guys had sort of been allowed to do whatever they wanted. They could pick their own infrastructure, so they had kind of a mishmash of things going on, and they really needed to consolidate and make it a consistent infrastructure and be able to deliver these services more seamlessly across their county and all the people they served. They moved over to the AWS Cloud, and they did it very quickly, and they are able to serve their citizens much more effectively and at a lower cost. State of Arizona, we had in our public sector breakfast that we had yesterday morning, the CIO of Arizona came and spoke with us, and pretty interesting. He's got a pretty complex and significant agency or a set of agencies he's working with, 130 agencies across the state. All of those employees, he's got 32,000 employees, and it's a complicated architecture. He's got 200 open projects going. They're ingesting 3 terabytes of data a day. And so he actually modeled his big, hairy, audacious goal on Amazon, and he looked at what do we say we're trying to do, and he decided that he was going to have a goal of every service available anywhere and at any time to every Arizonan. So that's a small idea that he has. So he really talked about 3 things that he's taken on. His DNS server, which that was driven by a crisis point because he had a failure of his DNS. Everything went down. In order to make that better, he added a second server, and then they had a power failure, so then both of them went down. So trying to find a better way to deal with that. So really, he was looking for resiliency when he took on that first project, but ultimately, he's actually had very significant savings, about three quarters of the project. He's only spending 25% now. In addition, they've consolidated and reduced their legacy servers. They've migrated 25 systems. They've got a 63% savings there. And then really having a new digital platform that includes a significant architecture of EC2 and RDS, IAM, and this is interesting because we've had analysts come and talk to us, and they're like, oh, is it just the easy stuff that people are doing? Is it just the websites? Is it just the test dev? Although, as we heard from Werner today, test dev's not the easy stuff necessarily. But this is, these are the kinds of things. It really is enterprise applications. It's the business applications, not just serving the websites, even though that's the citizen-facing piece of it. And very significant savings still. The interesting thing is a lot of people look at the numbers and they say, it looks like they're not spending that much money, so they must not be doing that much. That shows a incomplete understanding of what it actually costs to run Amazon Web Services. And the final one I'm going to talk to you about is the FDA. So the FDA has built a very significant new project called Open FDA. There were a number of components to this story. So they were trying to bring together information about foodborne illnesses and also drug interactions and make that, they try to bring it together and identify what was going on and try to solve problems for citizens, but also make that data available to the public. In the past, it had been a lot of paper-based systems. There were FOIA requests, which took a long time for people to get information. By the time that information got to the people who were trying to get it, there really wasn't much they could do about it. So there were problems that continued long after the issue had been identified. So they actually made use of a number of things, including Mechanical Turk. So they used Mechanical Turk to get all the data in. They actually found a way to do it with HIPAA compliance, where they broke the data down into chunks so that the pieces that were being captured, none of it could identify an individual because it was done in little bits. And then they also brought all of that data in and figured out a way to put it all together into databases so that they could pull it together and find ways to identify patterns. In terms of that piece of ingesting the data, they had 99.7% accuracy and reduced their costs from $29 per page to digitize it to 25 cents per page. So that was pretty significant. And then in terms of how they were bringing together those adverse events and trying to identify what was, where were their causes of problems. They had very interesting use of social media that they're doing, where they're pulling in data where people are saying, oh, I feel terrible on Facebook or on Twitter, and trying to geolocate that, put together the information to figure out, are those things happening in one place at one time? Are there common elements, in addition to things that have been reported by doctors, by people who are reporting things into the FDA? So really significant positive impact on their ability to serve their mission.
All right, so I'm going to talk to you about JPL, so the Jet Propulsion Laboratory. So the Jet Propulsion Laboratory is a part of NASA, and it's operated by Caltech. It's got about 5,000 employees, and they're based in California. And so one of the things they've done is they've sent 19 spacecraft, going back to the 2 Voyager spacecraft in the 70s, up into space to collect data for us to analyze. And so part of that is the Mars exploration program. And so they sent all these things out to Mars, and one of those was the Mars Curiosity rover. So the Mars Curiosity rover landed in late 2011, and they had a project where they wanted to live stream the landing of the rover. This was a technically challenging project. And then for a geek like me, this is the fun stuff in the project. So they were streaming NASA TV, which is an HD television stream. They were expecting about 1 million viewers on the stream, and it needed to support all your common playback devices, so iOS, Android, Flash streaming, HTML5, all that kind of stuff. They were expecting about 1 megabyte a second or 1 megabit a second per viewer, so they knew about how much bandwidth they needed, and it was a once-in-a-lifetime opportunity. The landing's going to happen once, and so everything had to work because you can get a do-over, you can push the landing, right? So everything had to be in place and properly set up. Now, they faced some interesting challenges here. So this is the stuff that's not so fun. They found out, so NASA obviously has a live streaming setup that they use, and they found out that they couldn't use it. They found this out 6 days before the landing. So they had no live stream set up for this Curiosity rover landing 6 days ahead of time. Now, okay, so you could provision some space on a content delivery network, no big deal, right? Well, it was also the same week as the Olympics, so what that means was there's a crunch on CDN capacity across, various providers, so they couldn't just go out there and buy capacity from a content delivery network. The other challenge they had was they had a really small team. They had 2 people available to work on this, And I think there were about 2 people from Amazon that were also available to work on this. So they had a really small team, and they needed to get really big results. So let's talk about the technical problem or the technical challenge with streaming video. So the way video streams work is, you have your video files, and they're typically saved in 4 megabyte segments. So that's a fairly big file size. So you just keep adding segments. And then you have this file called a manifest file. And that file is what tells your player in your web browser which of those segments to play. So once a video stream file, the 4 megabyte file has been has been written, that's never going to change. You just keep writing new files as the live stream goes on. The manifest changes every 4 seconds because it tells your player, oh, hey, I need to load the next segment. So the 4 megabyte file you can cache, right? So you can cache it, you can put it on the CDN. The little manifest file you can't cache. So that makes, or it's very difficult to cache it. So they designed a plan, and this is what's really amazing, because with Amazon Web Services, in 6 days they planned a solution, they executed on that solution. And this is something that just wouldn't have been possible in old world on-premise infrastructure. So they did some testing, and they figured out that the origin, so the origin is basically the server that the stream is originating from. So there's a laptop like this, and that has the actual stream plugged into it, and the laptop is sending that video up to an origin server. It's either a Flash Media server or a Wazoo server. There's a bunch of software that they can use for that. And so they figure out they can only support 6 connections per 1 origin server. Obviously, that's not going to be enough for the 1 million viewers they need. They also then said, okay, well, we can put a cache in front of it. So the cache just saves those big 4 megabyte files, and it sends them out, right? So they can have 20 connections per cache node. So then they decided, okay, well, we can have 2 layers of cache nodes. So that expands things considerably. Also, because it's a video stream, it's a latency, it's an application that really depends on low latency, right? So when you're watching a stream, you want it to not have a lag time. So it's really important to distribute your instances for your stream all around the world, because you're going to have viewers for this sort of thing all around the world. And they also reserved basically, or they were going to use one of our regions, US West 1, which is the one in North California, for S3 capacity. So they were going to get static images eventually sent from the actual rover. They were going to save those static images in the S3 bucket, in an S3 bucket in the West Coast region. So what that allows them to do is basically, S3, one of the things you can do with it is that you can host static assets on it, such as images, JavaScript, CSS files. So that way they didn't need an EC2 instance. They didn't need any compute at all to just serve up the static assets. So that significantly made their architecture way simpler. Then, once they planned this out, they had to really test it. They had to ensure confidence that it was going to work, because again, they didn't have a do-over. So again, they had 2 guys that worked on this. Luckily, one of them was a rocket scientist. So when you have really talented staff, that helps a lot too, obviously. And actually, so Quadrant now works for Amazon Web Services. And so here's the actual architecture that they came up with. So what this is you have your actual laptop that has your video stream plugged into it, so it had NASA TV streaming through it, and it would send it out to 2 Adobe Flash Media servers. So a primary and a secondary. So if the primary failed, they could fail over to the secondary. And then that would get cached by 2 tiers of Nginx caches. So these were just Nginx, groups of Nginx instances. And this was spread around 2 different availability zones. So it was architected for high availability. So if something happened to one availability zone, you would still have your secondary Flash Media server in another availability zone. And then there was an Amazon Elastic Load Balancer in front of it. So your actual stream could just point to one of the Elastic Load Balancers and get the video to the player so folks could see it. Now, they also did use CloudFront, which is our content delivery network, but they only used it for museum partners. So they had some museums around the world that had theaters that were showing this live stream, and so that's what it was used for. Now, the really beautiful thing about this setup is that it's a CloudFormation stack. So what this means is they could spin up one of these called 42 packs because they had 42 instances in them. So they could spin up one of these on demand. So you just take your CloudFormation as our service that allows you to define, your Elastic Load Balancers and your instances and whatever artifacts you have in your AWS architecture, and you put in a file, and you can deploy it off of that file. So they could go and deploy one of these 42 packs in any region that they wanted to based on their needs. So if they, during the live stream decided, oh, I need more capacity, they could just launch it and they had that capacity. So then they had to load test it. So I'm actually going to be doing a session on load testing tomorrow at 10 a.m. So if you want to find out more in-depth information about load testing, you can come to it. But what they ended up doing was they used a tool called SOASTA, which is a third-party load testing tool. I think they have a booth down in the expo area. And so they were testing it just to be safe, as you can see there, for 10 million users. They just wanted it to be safe. They were estimating 1, but they just did it times 10. And so what they were actually testing for was bandwidth usage, right? So video streaming is all about just outgoing bandwidth. And so you want to make sure it supports the right levels of bandwidth. So they'd spin one of these stacks up, and then they would test it to see if they got stable, consistent bandwidth. And you should be able to predict the bandwidth just based on how many instances they have. They can support a certain amount of connections. I think it was 20. And so you have 42 instances. So they wanted to make sure that it lined up with their math. And it did. So what they saw was that they were getting, off of each one of these 42 packs, they were getting 25 gigabits a second of bandwidth. So every time they launched one of these CloudFormation templates, they could get 25 gigabits more. So then what they needed to test was, is our caching working, right? So you want that 25 gigabits to be coming out of your actual your streaming, your caching servers that are running Nginx. You don't want them to hit your flash media server because that's not going to have enough capacity to support that kind of bandwidth. So what they then looked for is how much bandwidth is coming out of our flash media server into the caches. And that was only 42 megabits a second. So it was a small fraction of the total bandwidth. So that means their caching was actually working, and it could sustain this level of traffic. So they ended up getting beautiful pictures and live stream, and everything worked. And it worked really well, and so they were really happy with that. Now, they learned some interesting things from it. They learned that testing delivers confidence. So if they didn't test this, they would have had no idea going into the day that the rover was landing, this was going to work or not. It was all theoretical. So the fact that they tested it gave them a lot more confidence that this was actually going to work. They used AWS CloudFormation it made their operations really easy. If they had to manually set up 42 instances every time they wanted capacity, that would have taken a lot of time. That would have wasted a lot of time that they didn't have since they only had 6 days. So they were able to use CloudFormation for automatically spinning up their architecture. They also learned that you should really test thoroughly. So we were talking about testing bandwidth, but it's a thing that you don't test that usually breaks. And so what happened in this case was, they had a lot of capacity for their live stream, but the actual player that was hosting the video was hosted off a content management system that was on a really small instance with a really small RDS instance in one availability zone. It wasn't multi-AZ. So had they not discovered that, their stream would have been great, but their player would have crashed and nobody would have seen the stream. So it's good that they went through and discovered that and upsized their content management system as well. They learned that AWS services can scale big. If you think about it, in 6 days, they were able to create essentially their own content delivery network. They were able to plan it and create it in only 6 days, which is amazing. And small teams can scale big. It doesn't matter how many servers you're operating on or what it is. If you use automation and proper deployment techniques, you can scale really big with a really small team with 2 people. And so the other interesting thing about this was, I told you they used US West 1 for their S3 images. So this was the actual first image that was sent off the Mars rover. There's obviously lag between here and Mars, so it took a little while. So when it got there, it was put in this S3 bucket, and the total bandwidth consumed by this one little image was actually ended up being greater than the whole bandwidth for the HD live stream that I was just talking about. And the cool thing is because it was hosted on S3, S3 is designed, it sees about a peak of 1.1 million transactions per second against it. So it served up this image just fine. They didn't have to worry about scaling it at all, just uploaded this image to S3 and it just worked. So again, AWS services can scale big. That's the other thing they learned from it.
you know, you heard about a bunch of different kinds of governments that are using AWS for many different use cases. I wanted to give you confidence today that governments are in fact adopting AWS. We're finding not just those real innovators and visionaries. That's definitely where it started. Certainly Tom Soderstrom at NASA JPL is probably one of the most innovative of those bleeding edge innovators, but I don't know that, you know, necessarily all of these CIOs or administrators of programs that we've heard about today are among that crowd. They may have a little glimmer of that, but I think we are reaching the early majority among, you know, among the government users. Those who want this will find a way to get it. So even, you know, those who are sort of limited by the procurement regimes or who don't really have a clear policy about whether they can or can't use it, if they really find a compelling reason to make use of the technology, they'll find a way around, just like Terry Halverson did by going to SPA and then bringing AWS in that way. What matters most? Yes, it's cost, definitely, but time matters a lot. There are a ton of things like landing the Mars rover, like dealing with crisis in delivering food stamps, like being able to cope with major disease outbreaks. These things, time matters more than money. And when you can deal with the time factor and the money comes with it, then that's fantastic. And then also performance. You can't have citizens who are trying to use the tube in London or people who are trying to watch the landing of this historic event. You can't have those people, you know, dissatisfied. And finally, the thing that matters to all of us who are working in public sector is really making a difference and improving the lives of citizens. Thank you very much.